Kindly be seated as we start the session. Let me call upon all the speakers that we have today, particularly for the track 2, which is in-orbit technologies, from solutions for increasing life expectancy of satellites by refueling to in-orbit servicing, orbital transfers and collision avoidance services through SSA and STM, and further deorbiting and space debris removal. There are opportunities to service this business requirements. And to talk about this particular topic, we have amazing set of speakers. And I'd like to call upon everyone on the stage. To begin with, Mr. Chethan Kumar, Assistant Editor, The Times of India. Welcome you. I would also like to call upon Mr. Piyush, Director, GM, India, Space Missions Co. Thank you so much for joining. Retired Air Commodore Terivan Haren, Managing Director, Leolabs. Kindly join us. I would also like to call upon Mr. Rohan M. Ganpathy, CEO and CTO, Bellatrix Aerospace. Mr. Tanveer Ahmed, co-founder and CTO, Digantara. Mr. Ashtesh Kumar, CTO, Manastu Space. And Mr. Navin Gopal, Head of Strategy and Business Analysis, Astroscale, to join us. Thank you so much for joining. I let Chethan to take over the panel.
Is this audible? Yeah. Thank you so much for the introductions. And I think given the time that we are in, the times that we are in, the evolution that the space sector is going through across the world, from mammoth organizations continuing to fund in, and a constellation of new companies, small and big, from the private sector, also making contributions significantly, some in a smaller magnitude and some much larger. In that context, I think I have with me a great panel to look into in-orbit technologies, which I think will be very critical when we speak of sustainability in space. As your orbits get more crowded and more space assets get created, there is a lot of potential and I think a lot of responsibility when we speak of in-orbit technologies, whether it's refueling, as she was speaking, or whether it is servicing. We've had some work done over the years, the space station, but I think the future, as we speak, this is the decade of space, and I think from here it's only going to move forward. So in that context, without taking much time, I think I'll have my panelists introduce themselves and the kind of work they're doing so that we can get into a more meaningful discussion rather than my words colliding with time and eating into theirs. So if we can start, I'll start with Piyush for convenience. And then if all of them could take their turns, please.
Thanks, Chethan. Good afternoon, everybody. At the outset, I'm Piyush from Space Machines Company. At the outset, thanks to SIA-INDIA for putting us together, allowing us this platform. I also want to quickly mention what a big week this has been. What a fitting Diwali week it's been, with ISRO doing this massive launch and the Indian cricket team doing this famous win. So congratulations to everybody in the room and happy Diwali. A little bit about Space Machines Company and what we do and the role that we play in in-orbit technologies, which is the theme of the panel today. So the inception or the origin story, if you will, is in the ambition of creating factories in space. And when you delve deeper into that problem statement, very quickly it emerges that in order to enable any manufacturing in space, you need the ability to be able to move from point A to point B in space. And when you start to scratch that problem statement a wee bit more, you start to also understand that as you solve that problem, it opens up the doors to various dual use cases. And examples of some of those, and they've been spoken at length through today by Dr. Somnath, Dr. Lele, you know, Mr. Chand from Viasat. So it's already front and center. And some of these use cases are launch, going from ground to anywhere in space. That's the transport vertical. The second would be on-orbit services, which would include life extension, refueling, etc., debris removal, proximity ops, repairs, and the third would be in service of science, in deep space exploration, the ability to go more frequently, farther, and at lower cost to go and explore space. Now, this was essentially the context that started Space Machines Company. And while we were toying with these ideas inside our head, the world was already innovating around the first mile, which is, you know, to get off the ground. We brought our focus to the entirety of the customer journey and went a little beyond the first mile, included the first mile, and went a little beyond to include the last mile as well, in order to deliver the entirety of our customers' outcomes. And that basically, that thought process has resulted in conversation with our customers in an OTV, an orbital transfer vehicle, which we call Optimus, and that's flying next year. So that's a little bit about the company. So just to summarize what this means for our customers in terms of customer experience. The conversations are much simplified. The conversations that we now have with our customers are essentially anchored on three data parameters, 3 data points that we have these conversations around. One is what size is your payload? 2 is when do you want to get up there? And 3 is what orbital parameters do you want to be inserted in? And just the fact that we've been able to simplify this conversation has, we've also created a term around it. It's called peace of mind space logistics. And peace of mind space logistics also comes at a cracking price point, right? If I may say so myself. So, and we're able to deliver on that price point through the cost benefit that comes from a modular design and a hub and spoke model. So, if I were to, just encapsulate everything that I've told you so far, and to give you an Earth analogy, something like a FedEx or one of these ground logistics service providers would probably come very close. When you give your package over to FedEx, you don't care about the truck. You don't care about the tires, the engine, the fuel. You just give them the package. And when the package arrives at its destination, you get a notification. And that is somewhat similar to what we want to do in space, starting out, and then expand to other use cases as well. So without taking much more time, I believe that's 5 minutes. That's us, that's Space Machines Company. I'm going to be here all 3 days. Let's talk, let's collaborate. Thank you.
Thank you, Piyush. And look, it's my great pleasure to be here today. And also I'd like to say happy Diwali. Well done, ISRO, on launching OneWeb on the weekend. And in fact, they're our customers. So we're very happy to see another 36 satellites in low Earth orbit, which we are now providing collision avoidance services to. And last but not least, well done to the Indian nation with your game of T20 cricket on Sunday. Virat Kohli, 85 of 53 balls, was just a fantastic innings. But if he's in that form, I think India's going to be in the final, and maybe Australia meets you there to have another challenge on the real battlefield of cricket. I'm just retired from our Air Force, and my last job was the Aerospace attaché in Washington. And I learnt about this new phenomena called the new space race, or Space 2.0. And it's a space race that's basically occurring more in low Earth orbit than anywhere else. An exponential growth of satellites. It was like 500 or so satellites 10 years ago. There's over 5,000 active satellites there today. And a space race which is largely commercial. Largely commercial. Lots of commercial operations and commercial innovation going on to bring space to all users and to solve many problems. So in that context, Leolabs, the company I run in Australia, which is a subsidiary of an American company from Silicon Valley, we're aiming to be what we call the end-to-end mapping platform for this new environment, sort of like Google Maps for space. And there's a tremendous challenge in keeping up with the changes and the growth that's occurring in the space environment. The way we approach that is, firstly, we're a commercial radar company, phased array radars, which we're building all around the world. This year, we'll actually commission our 6th site, our 9th and 10th radar, in Western Australia, near Perth. So that's a radar that we're building at the moment. This technology is, firstly, using a commercial electronics type grade of technology, which scales very quickly. So this year, in fact, we'll build 4 radars on 2 new sites. Next year, we plan to build 4 new sites, and we've got a plan to build up to 20 radar systems all around the world. Now, everyone should understand phased array radar technology is a game changer, because when you have phased array radar technology, your radars are now capable of capturing a lot of data very quickly. And the radars that we're deploying now are in the S-band, so 3 gig, and their wavelength's about 10 centimetres. They're designed to see small objects in low Earth orbit the size of this golf ball. And we can certainly start to measure these objects. And this is the first thing. We're trying to bring a data-driven transparency to the space environment. And that data was then basically the critical data for all the missions that we'll talk about today. We will slowly build up our catalogue, but also by having a high population of radars all around the world, we're talking about real-time tracking of objects. And from that, then we run our analytics to provide the other services. We're also concerned about sustainability in low Earth orbit. At the moment, we know there's about 20,000 well-tracked objects, about 10 centimetres and above, but there's in the order of 250,000 objects between this size and 10 centimetres that are currently untracked. And unfortunately, that's travelling at 7.5 kilometres per second, and it's lethal to anything it hits. So our challenge there is to use this data to provide the collision avoidance services that we currently do provide, but also extend it into the small debris area to provide enough information for operators to operate safely in that environment and efficiently. The other side of the coin in space is it's very congested, but it's also contested. There's a security issue always in space. And what we've learned recently is that, again, it's a data problem. We're trying to bring deterrence into the space environment too by providing a data source independent of government, so a commercial data source. And you can see what's happening in Ukraine. Ukraine is doing well on the battlefield because it's getting commercial imagery, commercial satellite communications and internet services. And we believe we can provide that same sort of data sets to many nations all around the world to give them an advantage over their adversaries and keep deterrence alive. And in fact, it's even more important than that, because now the big commercial satellite companies are also have security risks. And if you haven't picked up in the press, both the Russians and the Chinese are talking about how to disable, degrade or destroy Starlink, who are one of our customers. So, you know, with data and transparency, we're trying to look at sustainability issues and deterrence, but more importantly, if you go back to the Google Maps analogy, we're actually trying to promote growth in the commercial space industry. And we do that provide tailored services to different companies. We already have a lot of the bigger satellite companies flying off our data today. But, you know, collectively, with all the innovations that are going on and the commercial growth of space, we want to see the space applications. So on top of Google Maps, you've got like Uber and Waze and all these other wonderful things. They are applications. They can be built on great data sets, and we're aiming to provide that data. So I think that's a quick introduction to Leolabs. And this is going to be a very interesting panel. Thank you.
Good afternoon, ladies and gentlemen. Thank you, Chethan. It's good to be back after the COVID, finally seeing everyone face to face. I represent this company called Bellatrix Aerospace. We are based out of Bangalore, India. And yes, we didn't name our company after the Harry Potter character. We are primarily a technology company, a space transportation company, and one of the very few early space companies in India. So we started this company when I was 19 years old in 2012. And we specialize in propulsion systems, primarily electric propulsion and green chemical propulsion. And we made the world's smallest thruster, as small as your fingernail. We also make thrusters or engines which can fit into larger communication class of satellites. And we are completely vertically integrated. And that being said, took us on a different path of vertical integration where multiple technologies had to be developed. So what we are working on is, for example, can you 3D print in zero gravity? That's something which we have actually demonstrated that. So, and not plastic, I'm talking about metal additive manufacturing. And when you have such capabilities, we found that when you're connecting the dots, all you needed was a transportation service. So how do you align Bellatrix from a technology company to a space transportation company? Took us on a path to develop something what we call as space taxis or OTVs, orbital transportation vehicles. And looking at, majority of the satellites which are being miniaturized these days, so they cannot afford to take, a ride on a bigger satellite as a primary customer. They always have to be a secondary customer. And they have to wait to get to the right inclination, to the right orbit. And in terms of launch frequencies other than SpaceX, it was all about 4-5 launches a year. So to bridge that gap, these so-called space taxis prove a good way to do it, and that's something we are going to do. But what we want to do is make them reusable, like not go deliver and your job is done. Rather, either you use, because with our electric propulsion, you can either deorbit, because your orbital slots are becoming like real estate in space. So it's going to be expensive. So how do you clear the debris, or like something like what Northrop Grumman demonstrated, extend the life of a satellite. So there are a lot of potential capabilities which you're talking into. So the architecture, what we saw when we want to build our OTVs, how can it be multi-mission capable, not just a single one? Either aid in manufacturing in orbit, refuel in orbit, because we want to make it reusable, and also help in debris removal. So that's how we started. And when I say we are doing this, we are working with industry, where we stick to our own specialization, that's propulsion. But other technologies, we work with partners, such as my friend here, Tanveer from Digantara. Their SSA would help us in collision avoidance. I'll come to you as well. So you see, space as an ecosystem, we have to work together to give a solution, meaningful solution, which works at the end of the day. So that's how we have structured it. And we have literally seen the Indian space ecosystem from fully government control to now what you see today. So I'm very happy to play a small role in the global space 2.0. And that's about Bellatrix. Thank you.
Hello, I'm Tanveer, co-founder and CTO of Digantara. So my company's name Digantara, it means a faraway domain, a faraway land, space in Sanskrit. So as a company, we want to make space as a business domain that is sustainable. When we started out, it was essentially, working around the problem. I think Terry pointed it out that, the ball that he has bought, those are the objects that are untrackable or undetectable, but yet lethal enough to kill a satellite. That's where we started out, but eventually we realized that, look, without a vision, tracking or doing surveillance made no sense. Why are we doing this? We started asking this question to ourselves. So that's where we took a step back and realized that whenever a new business domain is created, it's very natural that industry sponsors upon and exploits and starts to exploit the resources. And it's very natural to realize that the space industry is not the great keeper of the domain it operates in. But for space to become a resilient business ecosystem, the industry operations and its sustainability has to go hand in hand. So that's where Digantara is creating an infrastructure layer for space ecosystem that will ensure both the space industry's operations and sustainability go hand in hand. We're doing this in 2 steps. So first thing is gathering the data. So we are building our own sensors, both ground-based and space-based, so that we can we have the potential to expand the catalog size that is currently existing. And the second step is to develop proprietary algorithms, so the software to first step is to do the orbital processing and then to deliver cutting edge use cases. And essentially all the esteemed panelists I have here with me on stage, whatever they want to do, be it launching OTVs, doing high-tech maneuvering, and Astroscale is on a very futuristic ambitions on deorbiting. So this essentially would require them to know what's happening in space, and that's exactly what we try to do. We try to make sure that our solution integrates into their application as an infrastructure layer that will make their operations seamless, very neat, at the same time ensuring that the industry is moving towards sustainability. Yeah.
So, good afternoon, everyone. I'm Ashtesh Kumar, CTO and founder of Manastu Space. So, Manastu Space is a space tech startup which was born in Mumbai in IIT Bombay in 2017. And we started with the vision of being the next in-space services and logistics company. And how this vision actually came about is when me and my co-founder, after 8 years of hard work, we launched IIT Bombay's first student satellite in 2017. During this journey, we especially saw that how satellites are really leading the way of making disruptions on Earth, making changing the way we are solving problems on Earth, and especially to advantages which were extending to every last person on Earth, like applications like irrigation, agriculture, and whatnot. So we saw the huge spike in the number of satellites getting launched. Next 10 years, the numbers which are more than 60,000 satellites. So really huge numbers, right? And one of the key things what we saw was leading this change was the dirt cheap launch prices. With the innovations what companies like SpaceX and many other launch companies are doing. So we are having a lot of companies building cheaper launcher systems. Lot of companies building cheaper satellites. But once you have so many satellites in space, you have issues in space, right? Like on a highway, when you have so many cars, you need, they will collide with each other, they will run out of fuel. So we identified that there exists a need of a company which can serve this infrastructure when they are in space. So with this vision, Manastu Space was born, and we are currently building green propulsion systems for satellites and working with Indian Defense and some French customers as well to develop similar systems for upper stages of their launch vehicle. And in future, we want to augment this technology so that this technology can play important part in several more complex technologies like in-space refueling or automated collision avoidance systems, and make the in-space asset utilizations better so that this space can be made accessible for all in a sustainable manner. Thank you.
Am I coming through? All right, there you go. So, the problem with coming last after such an illustrious group is like, the analogy would be being the stand-up comedian that comes up after Aziz Ansari and Russell Peters. So, yeah, it's nowhere to go for me now. Hi, Glad to have everybody here today. My name is Navin Gopal. I'm the head of strategy and business analysis for Astroscale. Now, Astroscale is a space sustainability company that looks to forward the case of the circular economy into space. And when we talk about the sustainable space and the sustainable space economy, we talk about solutions across all orbits. So we are in LEO and GEO predominantly, but also in MEO. What a lot of people know us for is the work that we do in active debris removal and end-of-life deorbiting of prepared satellites. We are also doing work in resolved imagery in space SSA. We have a mission with JAXA launching next year, and we are forwarding that technology into unresolved imagery type functions. We are also in GEO. We provide fleet management services in GEO for GEO satellite life extension, relocation, sort of orbital alignment, relocation to graveyard orbit. And we're developing technologies in the near future to refuel in space, because we think that's a key element, and some of our panel members here have spoken about how important refueling can be to that process of enabling the space economy via these services. And we're also looking at developing technologies that can rescue beleaguered satellites, satellites that are tumbling at a certain degree, go in and grab and rescue and bring them back. Now, that is how we capture the spirit of space sustainability today, and we continue to evolve that into something that brings us closer towards a closed loop, rounded space economy that doesn't waste. And if we think about the space economy today, it really is a throwaway culture. We kind of put stuff up there and forget about it. That can't work. If we continue to do that, we are already at the precipice of a point in history where we could stop our access to space by being irresponsible. What Astroscale seeks to do is work with everybody, not just on a technology and a commercial level, but on a policy level, to think about what does responsible space behavior look like, what do policies that drive space responsibility and space sustainability look like, help everyone kind of get on board in terms of that perspective, and then build solutions that enable that to happen. We've all heard about that wonderful $1 trillion space economy. The thing is, that's not going to happen magically. A lot of the things that the panel is going to talk about today, a lot of the technology solutions that we're creating are going to be key to driving the realization of that space economy. The services that de-risk environments in space, that helps reduce the cost of solutions in space, that takes away the throwaway culture that translates into a lot more risk in space and makes space a lot more facilitated towards that huge boom that we're all excited about. On a final note, Astroscale is an in-orbit services company that actually is in orbit. In March of 2021, we launched our LSAD servicer. And since then, we've been testing and proving seminal technology that will enable us to fulfill our promise of sustainability, and for us to all eventually get to the point where we meet that $1 trillion space economy. Thank you.
I think we've managed to keep ourselves within the time limit, which means we now have the next 20-25 minutes where we discuss topics in a little more detail. And major takeaways from what you've heard so far, if you have to underline 2 or 3 things, it would be sustainability and the need to collaborate. And going back to some of the critical areas of technologies that will fuel this global space economy. And to begin with, I think, given that, was I audible before this? Yeah. So given that our orbits, especially LEO, is going to get more crowded, and the race to crowd satellites in GEO and MEO is also on, I think space situational awareness, like Tanveer was pointing out, to understand what's happening in space and how to make satellites sustainable, and also strategically speaking, to know not just your own assets and how to protect them, but also to understand where assets of adverse countries might be. I think SSA has a lot of implications, and India, for example, we still don't have a lot of space assets in orbit, but in just the first half of this year, I think ISRO has had to perform on average 2 collision avoidance maneuvers. And now you can imagine what the US or China would be doing with 10,000 and 8,000 space assets in LEO and GEO. So the kind of importance that SSA has, I think, is something that multiple members of my panel can speak. So I'll start with, say, Tanveer, and then Navin and Teddy could also chip in. The importance of this, and also not only in terms of strategy, but in terms of commercializing SSA, the data that Teddy was speaking about, providing commercial data for customers globally, because when space is opening up across the world, so how important is this, and what can people expect in the next decade in terms of technology and also collaboration?
So I think the first question was, is SSA relevant, in simple words? Second question is, how can we truly commercialize it, and what are the challenges there? So to answer your first question, it's pretty clear that space traffic is increasing. I mean, yes, we have mega constellations, but even if we remove them out of the picture, and if you analyze the rest of the lot, and say last 20 years data, from last 3 years, we are the number of objects that we are putting in space, the number of satellites, number of launches, they're increasing. I mean, there is a sharp increase in the number of objects that we are putting out there, plus the mega constellations. So right now it's pretty clear, because of the kind of space traffic we are dealing, and every launch leaving a significantly large footprints in terms of number of objects that are created or left in orbit. It's pretty evident that SSA is needed for reliable space operations. But coming towards the creating a full-fledged end-to-end space traffic management system, I think collaboration is really necessary. So like every other company, we started out to think that we'll come out as a knight in shining armor who would come and make space safe. But we realized that it's not one armor that can do it, but many swords have to come together to fight this war. Why I say that is, there are many catalogs. These are database of objects that have been tracked by government agencies that are available in open source, and it's pretty clear that they're not compatible with each other. It's not the same thing that they say. Yes, I believe it will be a drastic situations when we compare the catalogs in the private ecosystem, but that gives us a lesson that for us to create a safe space ecosystem in which space activities can be done seamlessly in an unhindered manner, the SSA ecosystem has to collaborate. We have to the government, the companies together, work together and complement each other's capability, and only then the true safe infrastructure layer can be created. So that's what we are.
Yeah, I'll jump in if you don't mind. So thanks, Tanveer. As we think about SSA, the beauty of SSA is super, super interesting, and it starts from the fact that the definition of SSA is still kind of up there in the air. We've looked at one definition, which is what we call unresolved imagery type in-space SSA. Leolabs does grounds up SSA, and really that solution around what we very generically throw out as SSA is fulfilled by many players doing very important work slightly differently. And you kind of have to bring all of this together for different applications, and sometimes for a single application, these different elements come together well. Let me start with a definition in the way we see in-space SSA, i.e. SSA that's done from space, very similar to what Tanveer has talked about and what we are doing as well. When you talk about in-space SSA, there are two forms, and the reason why I think it's important to define this, I think the functionality that goes into this is critical to how we start off in doing a lot of services in space. So one definition I put out earlier is this idea of resolved imagery SSA, a very focused view on a given target. You're either looking at a piece of debris, a rocket body, or a satellite, trying to identify something wrong with it, or trying to categorize it in order to fulfill a follow-on service, for example, grabbing it. And then you have unresolved imagery SSA, and that's a huge segment by itself, talking about looking at a big space and understanding what's happening around. That involves a lot of security needs. I think a lot of the conversations that have happened prior to this really talked about unresolved imagery SSA and how do you protect that increasing number of national assets or critical assets in space through these sort of services, and that's very important. There is a third aspect to SSA that really isn't traditional in its nature, and Astroscale thinks about it sort of in that step forward, because once you identify, categorize a problem, for example, you track a conjunction. In a scenario A, the conjunction is happening between two live satellites. You can do orbital maneuvers to kind of push it apart if the risk builds up to a point large enough. Scenario B, you have one with going capacity, fuel, etc., and another one is a piece of debris, for example, a dead piece of asset. Then the one with power can move, or it may find that if it moves, it may sacrifice too much fuel through orbital dynamics in order for it to go into deorbit mode. So there's a risk there. So how do we deal with that risk? We'll leave that for a second. And then, of course, we have a third scenario in SSA as that carry through when two pieces of debris not in control of their trajectory are in conjunction or in potential conjunction. When something like that happens, it's a case of no, you're just waiting for it to happen, you can't do anything, and then boom, it collides. I think there is a step forward beyond that in SSA that needs to happen, which is a question of actuation. In space, SSA is critical, one, in a identification of a scenario and the potential of that scenario occurring, categorizing the risk, and then being able to actuate a solution. So in the case of two pieces of debris coming together, being able to grab one, pulling it away, stopping the conjunction from occurring. In the case where debris is going to come to a satellite that really cannot expend fuel, you can move the satellite away and enable it to do its proper deorbit later. So SSA really is an exciting field. There is a breadth of capabilities, and you can see how the work that Leolabs does, Digantara, and what we're trying to do just really come together to build that industry, and it's really exciting.
Fantastic. I love all the explanations there. I don't have to do any of the explanations of conjunctions and how to mitigate collision risks in various orbits and things like that. But I think we all agree that it's absolutely fundamental that the SSA community and commercial SSA keep up with this great demand to solve these navigation, space traffic management issues, debris management issues in Earth's orbits, and it's especially in low Earth orbit, where it's probably the greatest risks. We now say that it is not achievable by national governments. Our yardstick is the US Space Surveillance Network. And in fact, our founders were working on academic programs to look at this problem that was coming, this fundamental issue. There was not enough data in space situation awareness of low Earth orbit. And the recommendation to the US government was to build more and more radars. But guess what? They built one radar called the US Space Fence. It cost 1.5 billion US to build it, and it costs 70 million US a year to run it. And they can't build 10 of them because they just don't have those resources. So now it is fundamental that the commercial space industries actually do scale this infrastructure and do build the data sets to enable all the other space operations that we want to see occurring. Today, I'll go to the data. The US Space Surveillance Network in low Earth orbit does around about 400,000 measurements a day. We are now just tipping over 500,000 measurements a day, and when those two new radar sites come online at the end of the year, we'll be at 800,000 measurements a day, tracking about 21,000 objects in low Earth orbit, but we aspire to track hundreds of thousands of maybe even smaller objects. We now produce 15 million conjunction data messages per day of potential collision risks in low Earth orbit. It sounds like a big number, it is. The way we do it is every time we measure an object, we propagate its orbit, we then run analysis against that object, against every other object in the catalogue, and then we're updating any conjunction risk of this object versus another object. And when I talk of those numbers, we usually are doing that with the two objects at a conjunction risk, you know, every few hours as we take another measurement. And this is the only way you can actually resolve these risks. And it's so important that we deliver that data, that information, to the operators. We typically do that direct into the mission systems for SpaceX, for example. So at the end of, well, they've got a high risk conjunction with, say, some space debris, they can then actually operate and make an executive decision and manoeuvre to avoid that potential collision risks. So what we're saying is this data set, this commercial SSA world now is absolutely fundamental for safe and efficient operations in Earth's orbits. It applies to the other orbits as well, and of course there's places for telescopes and for in-orbit type SSA solutions and other things to be built to make it a multi-orbital system, and that is also critical. But it very much is a data problem. So really our fundamental, you know, thing that we're trying to do is to try and solve that data issue by building more radar systems and getting high fidelity tracking on all objects. We eventually want to track every object as it goes around the Earth every 90 minutes. So we've got very high updates of everything that's going on. Remembering that Earth's orbits are no longer a static environment. There's manoeuvres occurring all the time. There's multiple launches a week from different nations, and they're not deploying 1 or 2 payloads anymore. We're deploying 36 the other day, 60 with the Starlink system. On some of the ride shares, up to 105 payloads in one launch. So it is a very, very, very dynamic system now, and it requires an information approach to actually solve. And that's what that's our core business, that data stuff, and the applications and services. But what are the derivatives? What can you do with that data set? What can you then, you know, what other servers can you add? What applications can be built? What maneuvers can be flown? What orbits and rendezvous? Can we do debris removal? Is another question. And certainly we're collaborating with a few of these companies that are actually wanting to do that, because we can help them maneuver to the debris, make rendezvous, and then do something about these problems. But it's really a commercial collaboration now that I think takes over and starts to aggressively try and solve some of these problems and make sure that the commercial growth in Earth orbit is, you know, a long and successful adventure. Thank you.
Thanks, Dave. So going forward, I think when we speak of OTVs and even refueling, I'll try and club a few questions together so that we could get answers. One I wanted to ask Piyush was, see, with SpaceX now having, you know, also slashed their rates, so what is the kind of market we look at when we speak of OTVs commercially and even otherwise? And also if Ashtesh and others could answer, when we speak of refueling and technologies to do that, where has the industry reached so far as having standardized systems are concerned, whether it's for docking or valves that for intake? So where is the industry right now, and what is the way forward? So Piyush, if you can take.
Thanks, Chethan. That's a great question. This market is still developing. It's a very new market. Although the value around this market and the value proposition that an ODV offers vis-a-vis what's available today is not lost on the industry in general. I can talk you through some of the advantages on, you know, around flying on Optimus, for example, because that's the one that's closest to my heart. So the first advantage is that you know, an OTV is compatible with multiple launchers. So you don't wait for a SpaceX manifest to clear up before you can fly on a SpaceX, right? That opens up a world of possibilities for you. So we're compatible with PSLV, a SpaceX, you know, a Rocket Lab, all the rockets in ISRO's arsenal. So that's basically giving out a level of flexibility to our customers. We also do, we like high energy missions. We do 3.5 kilometers per second delta V, which kind of takes you beyond the LEO space and starts to target the MEOs, the SSOs, the GEOs, in fact even LLO, and that's a roadmap item. The third value prop here would be the decreased launch cost. You don't really have to buy out the entire slot anymore. So as a small sat player or even an academic institution, you might not want to shell out the $1 million or the $1.5 million that a port really usually costs, or even with the announcement that SpaceX made recently at $275,000 for say a 2 kg CubeSat, right, or 2U or a 3U. And the other advantage is you're faster to your final intended orbit, which means you're faster to revenue. We don't drop you off at the town square. We take you home. Yeah. So that's the essence of the value proposition that we usually pitch to this market that is still developing. And the modular architecture allows us to build this out really quickly at a fraction of the cost that it takes today to build out a satellite. And there's been a fair degree of traction around this kind of pitch, this kind of thinking. There have been a fair number of takers. We're flying 5 customers next year, and that's just the start, just the coconut breaking.
Okay, to add to the second part of the question, Chethan, which you asked, regarding use of docking adapters, or those things. Okay, so what we are trying to address is modularity. The docking adapters, and if you want to refuel your satellite on our, say, petrol pumps in space, we are giving you, for example, if you are a satellite builder, you can take our fill and drain valve free of cost, which is designed as a fast fluid transfer device in space, which you can integrate it to your spacecraft, so that that particular valve is compatible with our refilling stations. So that's kind of a strategy which we are trying to address. And another one what we are trying to do is, see, what is more relevant here is, I think, what Mr. Piyush has already pointed out, that if a customer has to launch 3 satellites, for example, 150 kg class, in 3 different inclinations, that means he has to launch on three different launches altogether. So space taxi or OTV, on the other hand, with 8 kilometers per second, what we have packaged into our thing. So this huge inclination change is also possible in one mission. So that way you save a lot of cost. That is one. And another one, what we are trying to do is you're building these propulsion modules. If you don't want to hitch a ride on the OTV, you just modularly attach our systems to your satellite, and it does the job. So, so there is still relevance there, but this is just the starting point, because we are only seeing space in terms of deploying your satellites and that beaming down data. But there's more to it if you look at the long term. What about NASA recently opening up the lunar exploration to private companies? So gold is available underneath the ocean. Why don't you go and mine it? The cost of mining is more than the value of gold. It doesn't make sense. Similarly, if you want to do something commercial on the moon, surface of the moon, it's not commercially viable unless and until the transportation, the cargo is taken care. So there's a larger picture there where a lot of us are required to give solutions. So that's where the big relevance is. Yes?
Yeah, sorry. Yeah, I want to tag on to what Piyush was saying. So we're another company that's really looking forward to refueling in space happening, because we see a lot of advantages not just for ourselves, but for how we provide services to our customers. And one use case we've seen, and we've had conversations with customers around, again, this is quite a common use case. A geosatellite goes into orbit and somehow loses part of its payload. So it was a high throughput satellite that's now maybe delivering half its capacity. What can happen is that satellite could be redeployed in a new market that requires less bandwidth. Problem is, that whole movement trying to get it there, etc., could further shorten the lifespan of that satellite. If refueling comes into play, that is now a new game that geo operators can lean on and comfortably move that satellite into a new market, reserve that slot for something else that's high throughput that can be launched later, and still have that full lifespan for that satellite. The other thing about refueling that we are hoping the industry can crack is in geo, refueling as a practice is not complex. The orbital dynamics in geo, as you guys know, are a lot easier to address because of, well, we don't have as much gravitational tug. In LEO, it's a totally different story. We have done analysis around trying to fly spacecraft to go and get refueled, and the fuel burnt in order to get to the station is more than the fuel we want to get. So that really is a huge complexity that we believe will be cracked, and we're looking for industry to crack it. How do we think about refueling in low Earth orbit, in very complex orbital dynamic environments? What would the infrastructure look like?
Yeah. Just to add on to the point of Navin, I think one of the major challenges we see in the refueling business is the commercial feasibility of it. Like how large the spacecraft would be, how much fuel it will carry, how many satellites it will cater. These are some of the challenges which the commercial feasibility is still to be looked at. And apart from that, as you told, like standardization is still far away game in space industry. So I think one of the US startups which got invested into by Lockheed Martin, I think the startup name is OrbitFab. So they did an interesting thing where they open sourced the design of their docking adapter. So these are some of very good initiatives which are being done so that standardization can take place in the whole industry. Yeah.
I think we have another 15 minutes left, so I would make this my last question and anything else that the panelists might want to add on before we open it up. So one thing we haven't addressed so far is, we've all spoken about collaboration, but how do we collaborate? Because space, as much as the commercial potential, is also a very strategic sector. It is the fourth frontier that every nation wants to conquer and at least have deterrence, if not, showcase full lethal potential. So how do we blur these lines between, big industries that are funded by government and technologies that are created there, and how does the private sector come in? We've for a while now, we've had the US model, but since I have panelists from Australia here, I think what Australia is doing in the last few years is particularly of interest to me, because I think they have a very positive way of attracting not just technologies, but also a human resource capital. So if we could dwell a little bit on that, and how and why collaboration is important, and what are some of the hurdles that we foresee given the dual nature of space, that is.
Yeah, thank you. I mean, Australia's doesn't have a lot of history in space. We're really a new space nation trying to now go rapidly in terms of innovating and bringing new capabilities into space. But the government has certainly incentivised collaboration between industry and universities, for example. There's a number of programs there where companies such as Leolabs here are basically encouraged to work with the different universities to work on different problems. In most cases there, we're providing in-kind services, access to data, and also some of our knowledge and other systems to try and get these new things going. In fact, I should also declare, between Australia and India, the agency has got under a strategic initiative another amount of money, around 25 million Australian, to drive collaboration between industry and collaboration between Australian industry and Indian industry. And in fact, I'm supporting Space Machines Company, who have a major bid to build the space machine capability and launch it here in India, flown off Leolabs data for an example. So that's, I think, a very good approach, government incentivising industry in a collaborative sense to bring all our forces to bear to actually achieve new mission effects quickly, and obviously that helps us drive ourselves into new parts of space. So we're all encouraged by that. It's a very important part of the Australian program, and now very much reaching out to countries like India to incentivise us to not only do it in a national sense, but in an international sense, which is very important when you're in the space industry.
Thanks, Terry. That's absolutely. I mean, that's exactly the foundation that this conversation needs around collaboration, right? And quite honestly, look at this panel. There's a role for each one of us in the entire value chain, right? So that's a perfect example of collaboration. So the way we look at collaboration is around a couple of streams that must converge, and I believe are converging. Let's take stream number one, for example. That's the government, right? Governments around the world have ambition of creating and extending their own sovereign capability, and they are also open to talking to friendly governments around these sovereign capabilities. And just like Terry mentioned, Australia and India are a prime example of this. India has a rich and vibrant heritage and history in the space ecosystem. We have great talent. We have decades or probably centuries worth of experience across the entire talent that's available here. Australia has a rich history in ground stations and the willingness to go out and collaborate with strong ecosystems like India through the ISI grant, which is the 25 million grant that Terry was talking about. And so this kind of lends itself to the whole conversation around collaboration, because this is an intent that the governments are projecting onto the industry, saying, why don't you go out and get this done, and you have the government support to be able to do it. And then also supported by initiatives such as ECTA and within the frameworks of Quad to be able to meet the objectives of these initiatives. The second stream is the private entities, such as us, right? And the premise there is space is hard and is capital intensive, right? And here we are, complete, absolutely happy walking into that, as private entities. So I think there's a great degree of understanding in the private ecosystem around the fact that it takes more than one to get it done, right? Nobody that I've had the privilege of speaking to so far has said, no, I'm going to lone wolf it, right? I'll get it done myself. In fact, earlier this year during BSX, we had the opportunity of announcing an MOA with Anant Technologies that's based out of Bangalore. So there's some intent there. And third stream is the PEs and VCs, right? The governments can come in with policies and grants, but the PEs and VCs also need to come in with patient capital. So all in all, the way forward as we see it is collaboration that's driven by private entities, supported by governments through policies and grants, by VCs through capital, around clear outcomes, right? And this I remember was also a subject of conversation at BSX, wherein we recommended that the problem statements come from the customers. And a beautiful example of that was an announcement that was made not a few days ago, the Dev Space announcement. Those are problem statements originating from the customer, the government, with a grant around it. And the messaging is clear. It's like, you solve this problem, you have this money. And it eggs people on to start to collaborate, right? And from our perspective, and particularly coming to Space Machines company in India, we live and breathe collaboration, and we here in India for that whole reason. We have an office and R&D set up in India, in Bangalore, right next to iSight, which is ISRO's test facility, and just to get inspired on a daily basis. And there's encouragement from organizations such as, am I taking too long? Okay. So just quickly wrapping this point up, encouraging conversations from NCIL, InSpace, ISRO, and ISPA. Then there's support from organizations such as SIA. There's a great private launcher ecosystem here as well. So just, all in all, just plenty to collaborate around.
And just quickly to add to Chethan, what you've said, if we see space as a global industry, right? If that really needs to take off, US has to relook at its ITAR policies and clearly define what is national security and what is commercial, not bring commercial into ITAR sense, because US is still the biggest market globally when space is concerned. So if all of us from other countries has to explore US, of course through collaborations, they have to again clearly redefine ITAR. I'll end with that.
Hello, yeah. So the funny thing is, as we're sitting here talking about it, we're talking about collaboration. Leolab and Astroscale collaborate. Digantara and Astroscale have had quite a few conversations around potential collaboration. Piyush and I, before getting on, we're talking about, hey, we should talk to each other and see what we can do together. It really is a mindset thing with Space 2.0. We're not about, oh, this is all mine, and you do yours, I do mine. There really is this idea of compatimates. Sometimes we compete, sometimes we collaborate. And I think that's a really great mindset. And that isn't just as everyone has been saying, it's not just a commercial thing in Space 2.0. We all want to collaborate, we all want to see parts of how we can add value to the whole. And we're doing that together with agencies and governments around the world, the whole Australian-Indian relationship. Astroscale is doing a lot of work with partners in Singapore, in Korea. We hope to do a lot more with Israel, in India, and around the world. And I think the idea that space is global is the most absolute truth that was spoken today. I think we should believe that space is global. The LEO environment is a shared environment, and we must all treat it as a shared resource and deal with it together in a very collaborative form and in a way that's great for everyone.
Thanks, Navin. So I'll open it up to the audience now. If you have any questions, I would request you to be specific and precise. We have another 10 minutes left, so we'll try and take as many questions as possible. Thank you.
My name is Nikhil Arora, and I am from InSpace. So after listening to your conversations, now we see SSA as a big market. Now there's a key component here. When you predict a collision, the active satellite has to maneuver, and there has to be a collaboration between two. Both may be active, one may be active, one may be debris. Now this maneuvers, you have to spend some 20 grams or 50 grams of fuel based on satellite. How accurate is your SSA prediction? Simply you are telling, please maneuver, you are going to collide, and unnecessarily that fellow is doing a maneuver and spending a 20 or 50 grams of fuel. If the precision increases, a party A or vendor A gives me accuracy of X level, and second party is giving me a better accuracy, charging maybe a little more. But I'm happy to pay more to get a better accuracy to save my onboard fuel. Because paying some $10 or $50 extra saves me a fuel which is $200 or $500 in the grams. That is point number one regarding the SSA. Now coming to the second point, which we are talking about the sensors in the space and sensors in the ground, the phase array sensors and in-space sensors. Now you want to map all the things. Currently we have a policy like India, everybody should wear a helmet. So can we have a policy like each satellite of that class should carry a sensor so that the mapping is more accurate? That is one level. And the docking adapters for a bigger satellite, the docking adapter, because we cannot dock a satellite, old satellite, existing satellite. It should have a mechanical or electrical interfaces properly define a satellite, at least in one place, so the docking is possible. do we have to make it compulsory in a class of satellite that this adapter has to be put on the satellite? If we are bringing to that level, then only these things can be done in a more better way. Thank you.
Wow, that was a great question. You're right. There really is a choice to be made in that balance of all that information and what you're going to take out of that process. And let me start with your question around that adapter to deal with conjunctions and be able to move things around. And again, that is so insightful. And this is something that Astroscale absolutely believes in. So one of the things we have done is we have designed a magnetic capture plate that's a very simple, very cheap solution that can tagged onto a prepared satellite. So when we say we deorbit a prepared satellite, it carries a magnetic plate. We can then just go and capture that magnetic plate, move the satellite, deorbit it, do a whole bunch of stuff. We can connect with the satellite in a very cheap, efficient manner. And we're all talking about those wonderful 36 Leolabs satellites that have been put into the heavens. Those 36 Leolabs satellites carry a docking plate that was designed by Astroscale for that very same purpose. And you're right. One of the things we're really interested in is encouraging everyone to put these adapters on, especially if you're putting your satellites into LEO, so that companies here that are trying to help you do other things, SSA, etc., can help. And your point around that data being relevant, because in low Earth orbit you spend a lot of fuel trying to move around. You want that decision to be accurate. Leolab does great work there, and we want to be able to bring together all the data, possibly from different angles, and create an environment where you have a view of all of it in a way that really improves your decision point. So you don't necessarily have to make a decision between A and B where the distance in that difference could be very large, but A and B have a conglomerate of different data that comes in from different environments that help you make that decision better. And it's not that big a spread.
How about that? Yeah, I'll talk about accuracy of data and how important it is, and how important it is to continue to refine accuracy for the SSA purposes. But I'll just say that I'm really talking about low Earth orbit environment where radar is optimum. If you look at the US Space Surveillance Network, they mainly use radar to track all objects in low Earth orbit, and certainly that's our view as well. But we deliberately have a system which is self-calibrating against the instrumented and lased range of satellites in low Earth orbit. So we calibrate and really try and tighten up our radar capabilities. In the order of 20 metres, root mean squared, which is extremely important when you are going to try and run an analysis of one object versus another object. But more importantly, the uncertainty of a position of an object is also temporal, and as the uncertainty grows over time, then you have a bigger problem to work out conjunction risk. So that's why that revisit rate is so important, to keep the system extremely tight, the accuracies as basically as tight as you could possibly do with radar to resolve the conjunctions. I'll give you an example. Last week, it was last Thursday, I can't remember. Anyway, we were watching two rocket bodies, SL8 rocket bodies, that had a near miss in low Earth orbit. From memory, around about 750 kilometres. They missed by 45 metres. At the time of closest approach, the potential collision risk was 10 to the minus 7, so there was no real risk of collision. Having said that, we've been watching those two rocket bodies for a week and continually calculating the orbits of both rocket bodies and propagating and working out risk. And we typically then had probably 70 calculations trying to resolve this. 3 or 4 days out, the risk was about 1 in 100 because the uncertainties were big, but so important now we just keep measuring, keep calculating, keep resolving and reducing the uncertainty to have certainty at the end point. More importantly, that's the radar equation. What we actually do with our commercial customers, say Starlink for example, where we recognise a conjunction risk for a Starlink satellite, we also bring in the telemetry data from the satellites themselves. So that's very important. When that data comes in, we're now using that predominantly to measure the conjunction risk of that object versus the secondary object, which may be space debris, maybe junk, and it doesn't have telemetry, it has only radar data that will be able to track that. And this also helps us resolve the conjunction risk, and then enables Starlink to make a decision about 8 hours prior to conjunction as whether they're going to manoeuvre or not, and a very accurate decision based on really solid data and processed data. Could it be better? So the great question then is, in low Earth orbit, can we even get smaller or greater accuracy than 20 metres? Well, that's all a lot of physics there. I'm sure you appreciate some of that stuff, but we're starting to talk about lasers and other types of way of trying to resolve those risks. But maybe then we should talk about the other thing we do is, in this accurate comparison of one object to another in terms of radar data terms, these things start to take over when we're actually trying to enable rendezvous and proximity operations. That is, tracking both objects, helping a spacecraft to manoeuvre in the same plane and then close on another object. We can get you within 100 metres or so. You need then the sensors on board to take over and solve those problems. So a lot of these things that I'm talking about, we see on Earth, in similar navigation systems, your Waze system, your all the things that are derived off Google Maps. And some of this technology that we're experimenting with in space is really going to be the essence of the technologies for self-driving cars and other things on Earth. Again, accuracy of data is very important to get a lot of data updates, to go into the mission systems there to make the calculations. And then an onboard sensor capability as well to do the fine resolution of navigation is really what I think will happen in space.
So I think I'll quickly pitch in. Yeah. So I think we have less of time. I'll be very quick. So I think Terry and Navin has made it very clear that accuracy in SSA is necessary, and everyone is doing it in their own way. We are building our infrastructure in a way that we can associate data from multiple kind of sensors and create a common operation picture, and at the same time try to reduce the error. So I mean, yeah, your question that more accurate data is more reliable. Yes, all hands up for that. I'll come to a second question. That's where it's a bit interesting, where you mentioned a bit of regulatory framework and how we can demarcate boundaries. So I think Rohan mentioned that the ITAR issue. So I think it's high time that space industry, especially governments, this is not an issue we solve, you solve it. So putting the ball back to you. Clearly define what is military space and commercial space, and leave us alone in the commercial space. So I think first step, the opportunity that we have here is your Indian government. My Indian SSA company, there is here US SSA company, and recently in previous Prime Minister's visit, we signed an SSA agreement, and we are doing, I don't think so, I've not heard anything on that. Why don't we say 4 entities work together, try to define first set of boundaries and kind of take first steps towards what we can call ICAO for space. Why can't we do that? That's a question to you.
Thanks, Tanveer. I think we have time for one last short question, so we'll wrap it up with this.
Hi.
We have one behind.
This is Haren from Inspacity. This is again, I'm so sorry guys, again for Leolabs and Digantara. How close are we to some kind of a universal collision avoidance system, right? I mean, there are different players in the field that are working towards, getting somewhere by themselves. But I mean, if we see something like a collision avoidance systems for aircrafts, or if you have if you have cars colliding, if you have the safety bags up there, some sort of a uniform code is out there. I mean, how close would you say we are to that kind of a scenario where as a whole, the low Earth orbits are safe, so to say? Yeah.
I love that question because I can see it happening. I can see changes coming, which certainly encouraging to start to solve some of these space traffic management issues and debris type management issues. And I use that analogy, the Google Maps analogy, for a purpose, because we talk about a whole bunch of technology and applications to come along to solve these problems on Earth, and that therefore if they do similar approach, we can solve them in space. One thing I'll just point out though, I'm not sure you understand the relevance of a big decision was made in the United States about 3 weeks ago. And that was at the National Space Council. It was enacting Space Policy Directive number 3, which was saying the US Department of Defense was handing over space situation awareness and space traffic management to the Department of Commerce. So the Defence used to do all that stuff, and guess what? They couldn't solve the problem. They're going to hand it over to the Commerce Department, and the Office of Space Commerce now is starting to engineer these solutions. But what's really happening is the commercial space industry is starting to engineer the solutions. They're already moving forward and starting to drive new methods, new applications, new ways of actually reducing their own risks of operating in various orbits. And we think collaboration between the commercial space industry in a more aggressive form will actually start to solve some of these problems. We'll go to the Starlink constellation from SpaceX, who currently fly off our data. They see a need to share their own orbits and their plans, if you like, their ephemeris, the change of orbits with other commercial companies, and do that electronically and make it easy. So now, in a collaborative sense, the commercial space industry can actually manage itself. I think that'll happen before the regulators start to drive the solutions there. I'm encouraged by that because I've seen it in the use of Waze and other products here on Earth. And it's really up to the software developers, the innovators, and the commercial industry to have this probably more strategic type collaboration going on to drive some of these solutions forward. And they'll be technology based. I think they'll all be about sharing data. They'll also be about sharing your intent and your plans with other operators. And that's a really good world because that is highly automated and could be more reliable than a regulatory type issue between governments. So by the time the government's actually, like even the US government actually gets its head around this, I think many of these changes will already be happening between these companies. And some of these big companies now, they're the main investors. They're the ones that have the biggest issues, the major risks, and they're looking for the solutions themselves. So we're very encouraged what's happening, in the bigger commercial space industry. Hope that answers the question.
Yeah, that's really interesting way to answer that question, Terry. So Terry used the term, Google Maps for space. So yeah, so I think that's a very interesting way to answer your question. So to have a truly global SSA architecture, so essentially what we are talking, first thing, the space industry, I think right now realizes that SSA is no easy play. It's a very complex and a niche area, and it makes no sense for every company to develop in-house capability on SSA. So that's why a company is focused on SSA who have core expertise in SSA are necessary, and our work essentially is to bring the Google Maps. By that I mean we take away all the complexities and the nitty-gritties involved in the complete orbital mechanics of space situational awareness, and truly simplified to the extent of Google Maps where you can very easily understand. And use that information to reliably design your missions and execute your missions, and make sure while the mission is operating, you have in situ updates of what's happening to your mission. And that's exactly what we are doing at Digantara. I think second aspect is, although a simple solution like maps is needed, it has to be backed by a sort of credibility and transparency that let's draw an analogy to aviation sector that air traffic management enjoys. Like, there is surveillance tracking that we have very clear metrics that the entire data packet has to be transmitted and processed and displayed within 10 seconds. That is what surveillance is. And next, if it's in 1 minute, it's called tracking, and whatever beyond that is nothing. So that's pretty clear there. So that kind of common consensus is needed. I think the first part, making it simplifying for customers to actually use it and trust us, is there. But the second part of being completely transparent and trying to establish common definitions so that even that part is even the reliability part is very clear. I think there is a bit of work there.
Thank you. I think that's how much time we have. I'll give it back to the organizers. And before that, thank you, all of you. I think it was an insightful 18 minutes. And they're here for the next 2 days. I think we can catch up with them a little later if you have any more questions. Thanks.